a diameter that is perpendicular to a chord. Okay, so here's BD as our chord. Okay, and if the diameter, AC is the diameter, so AC intersects BD at a 90-degree angle. It has to be a 90-degree angle. Then it bisects the chord and its arc. So that means that this length and this length are the same, and the arc lengths are also the same. Okay, so whatever that arc was from here to here, whatever those degrees were, this is now half, and that's half. Okay, so let me draw that a little better. BD is perpendicular to AC. Okay, so BE and ED are going to be congruent. And then the arc BC and CD will also be congruent. Okay, and each of those are 1/2 of the arc BD, and this is 1/2 of the chord BD. So far, okay? Chords that are the same distance from the center of the circle are congruent. So my chords are PQ and TR are the chords. Okay, so here's my two chords, PQ and TR. Go ahead and highlight them. And what I'm saying is if they are the same distance from the center, so if we find a point that's perpendicular, distance is always perpendicular. So OU would be congruent to OS, and that's the distance from the center. And because of that, we would have that PQ is congruent to TR. And just put like O is the center. Perpendicular bisector of a chord contains the center of the circle. This is the same picture as before. So we have the chord, and what we'd have is BE is congruent to ED, and BD has to be perpendicular to AC. And then that means that AC has the center O on it. So that just tells us that that's the center. And then we can, from there, we can say, okay, well, if this is for sure the center, then we know that these lengths are the same because it's radius and or diameter, and you know, that we can make other assumptions from there. So those are the same length. Here we've been given a circle, and I have two chords that are the same length. And if I have two chords that are the same length, my arcs are also going to be the same length. So chords are equal means arcs are equal. Okay, so if this is X, this is also X. Now, this arc length is 160, but that doesn't mean this angle is 160. Okay, because our arc length angle is from the central angle. So this angle would be 160 from the center of the circle. So I just want you to be careful about that and don't say all of a sudden this angle over here is 160. Yeah, so just be really aware of that. Let me put this in better. Okay, so if this is the center, I can't draw. If that's the center, then this is 160 degrees. This is not 160, okay? So don't get those confused. The arc length angle has to be from the center of the circle, okay, just as a reminder. Okay, but I do know that the whole circle is 360 degrees, right? The whole circle, 360 degrees. I have 160 of it, and I have x and x. So I have two x's, and the 160 is going to be 360 degrees. Stretching your question? Okay. So 2x's plus 160 equals 360. Take away 160 from both sides, and 2x's will be 200. So they're 100 degrees each. Let's practice. Okay, ED. That's this arc right here. Well, what I know, because these distances are both 3, right? Because these are equal here, that tells me that these lengths are also equal. Because that's the theorem we just had. If they're the same distance from the center, then they're equal length. So what I know from here so far is that FO is equal to OG. AC is equal to ED. Now because AC and ED are equal, then the arc AC is going to be equal to the arc ED. So if this is 103, this is also 103. So far okay? Now the length of AC, if this O, and I continue across here, or continue down here, this would be a diameter if I lengthened it out. And this diameter happens to be perpendicular to this chord. So far okay? And perpendicular diameters bisect the chord, so I know that EG is equal to GD. So if this is 4, then this is also 4. Well, because AC is the same as ED, that means this is 4 and also that is 4. Okay, so AC would be 8. Does that make sense? Then the arc AE, well, I have 103, 103, and 94. The whole thing is 360, so I do the 360 minus the two 103s, minus the 94, which will give me, let me do it real quick. Is it 60? See, 360 minus 206 minus 94 is 60. Yeah. Okay, so that's the measure of AE, 60 degrees. And then AO, I have a right triangle. So 3 squared plus 4 squared equals C squared, because that's my hypotenuse. So 9 plus 16, which is 25, is equal to C squared. So C is 5, so the length of AO is 5. Okay, so we are incorporating a couple different theorems into here. We're incorporating the Pythagorean theorem. We're incorporating the two chords being the same distance from the center are equal. And then we're also incorporating that the perpendicular bisector from the diameter. Okay. Just going to go over it really quickly, just not the answers, but just the picture of what's all the same. Okay. So these are the same as these. And because this length is going to be the same as that length, then this is going to be the same as this, so all four of those are going to be the same. And then radius, radius, so those will be the same. And then, of course, I have my arc lengths that are the same. These two are the same as each other, which is also going to be the same as this one, which will be the same as each other. So far, okay? And then I would have right triangles if I were to draw another radius here. So that's all. Okay, here is where I talked about the inscribed angle theorem. So remember when we had that 160 degrees and I said the 160 degrees was coming from the center, not from the other side of the circle. The other side of the circle, if you have an angle creating an arc, is 1/2 of the length of the arc. Okay, so in our other example, if I have a circle that's a color I can see, okay, and where we had this coming like this and like this, and it was 160 degrees, that means this is going to be 80 degrees. It's half. Yeah. And then if you have another circle and I have another angle coming out, and I know that this angle is, say, 45 degrees, well, then this would be 90. Okay? And then from inside, from the center of the circle, this angle would be the 160 here, and from the center of the circle, this angle would be the 90. You know, if I drew them pretty, but you get what I'm saying. So just be very careful not to confuse this angle measure being the same as this angle measure being the same. Okay, so this from the center, same, from the other side, half. Not too bad? So then we have another one that if we have a tangent, so ED is tangent, ED is a tangent line or tangent segment. So I'm just going to say tangent line because it could continue past here. And then we have an arc. Okay. Then this angle DEF is also, that should be FE. Not DE. DE is not even arc. Sorry. Okay, so we have the angle, this angle here is 1/2 of this arc here. So same basic kind of idea. So if arc length, the measure of FE is 80, then angle DEF would be 40. Okay. I have two angles right here coming from, you know, if I have one angle yellow, one angle green. Okay. What that's going to tell me is that the measure of the green angle, GJH, is going to be equal to the measure of the yellow angle, GIH. Because the arc GH is the same for both. Okay, and each of them is going to be 1/2 of the arc GH. Okay, so when you look at something like this, find the angles and recognize that this is not in the center of the circle. Okay. Here I have one angle that's green, one angle that's yellow, right? I have a red angle, and I have a blue angle. 4 angles, 4 vertices. Okay. Oops, pencil. Okay, the measure of angle K plus the measure of angle M is going to be 180 degrees because they're going to make together half of this. Yeah, basically, because each of these, well, here's why. Because, let me erase that. Together they make the whole circle, but MN or LN is twice the measure of M, right? And LN is twice the measure of K. Altogether that's 360, the blue and the red, but these are each half of the 360, each part that makes the 360. So then they're half of the whole circle, so they're 180. And then you get the same thing with angle L and angle N for the same reason, because N makes arc KM and L makes arc KM. Together they're 360, but each of the angles is half of the arcs, so half of the circle, 180. Good? Okay. And then finally we have this PRS thing with a point Q. The measure of angle PRS is 90 degrees. And I know that because this is a semicircle. And a semicircle is 180, and so this is half of that. Okay, and that's when PR is a diameter. Also, that makes PQR a semicircle. And remember, I have to use 3 letters because it's a major arc, because it's 180 degrees or greater. And remember, our minor arcs are less than 180 degrees, so we only have to use 2 letters. Okay, so major arcs are semicircle. So, any questions about that? All right, angle Y connects with this arc right here, which is 140. So the measure of angle Y would be 70 degrees because it's going to be half. And then angle X is 1/2 of Z. So I'm just going to write that down. The measure of angle X is equal to 1/2 of Z. No, we had to find Z first. We know X is half of Z, but I don't know what Z is. But I do know that this is 140 and that this is 80 and that the whole circle is 360. So Z is going to be 360 minus 80 and minus 140. So that's 220. So 360 minus 220 is 140. Okay, so yeah, I guess it is also 70, but we needed to double check it. So Z is 140. Which makes X also 70. So if this had been 90 or something, it would have worked out differently. Questions on that one? I know that because angle Y and angle X both share the arc for Z, as soon as I know Z, I'll know X and Y. So I have to find Z first. And Z is 360 minus 63 and 88 and 107, which I don't feel like doing in my head. So 102, which makes X and Y 51 each. Okay. Here I know that Y and 93 will add up to 180. So Y is equal to 180 minus 93, so that will be 90 minus 3, so 87. And since this is 93, I know that this whole length here is twice that. So the red is 2 times 93, which would be 186. And Z, no, not yet. Hold on. Oh, okay. Yeah, I need to find this part first. Sorry. I know that the blue is 2 times 72, which is 144. And that this part of it's 61. So I can find this other part over here by doing 144 minus 61. Are we following me so far? Okay. So 144 minus 61 is 83. So since this is 83 and the whole red is 96, I take the 83 away, and now I know Z. Z is 103. And then to find X, I now know 103 and 83 and 61. So I can just find X by subtracting all of those from 360. Or I know that Y is 87, so I could double Y and then subtract 61 to find X. So there's 2 ways to find X at that point. Which way do you guys like better? Subtracting everything from 360 or doubling and subtracting 61? Okay, so I'm going to double 87, which is going to give me 174. And then I'm going to take 61 away from that, which is going to give me 113 for X. So far okay? Not too bad? Alright. We have our angle Y, which is going to be half of that arc length, which is 94. So Y is 1/2 of 94, which is 47. Okay. X is on a semicircle. So X is 180 degrees. And so now I know 94 and 180. So I can find Z using the 360, that's the whole circle. Or I know that this is 90 here, so this would be 90 right there, and I could take 47 from 90 and find this angle. So there's another 2 ways I could find Z. I'm just going to use the whole circle. So minus 94 and minus 180. So that's actually 180 minus 94, which is 180 minus 90, which is 90 minus 4, which is 86. Okay. Here we have another one of these situations. Y plus 86 would be 180. So that makes Y 94. Because I subtract 86 from both sides. And I know that X plus 84 is 180, so that makes X 96, because I subtract 84 from both sides. So this is 96, and this is 94, and I know that Z plus 72, all of that right there is going to be 2 times 94, so 188. and I take away the 72, and I have 116, and that gives me Z.